I'm tracking a severe weather threat for today in the Ohio Valley into the mid-Atlantic here. And as we look at this, this is the one radar depiction from the NAM, 3 kilometer, showing updraft Helicity and storms here, with different pushes of storms here to the east here with high reflectivity values could lead to high wind impacts here, rotating storms within this line, okay? And the tornado risk is also not zero, but you see some rotating updrafts here as well. And then on the backside of this, you see storms initializing as well out west here in parts of the Ohio Valley from Indiana, um, Illinois, and points to the southwest. But so we have two distinct areas of severe threat: the Mid-Atlantic and the Ohio Valley. And in today's severe weather outlook, we're going to talk about these things in all different parameter spaces and go over the SPC outlook and give you all the best detailed information I can about this threat today. So this is the latest SPC update. Okay, so the categorical risk here, this was updated just a little bit ago. So I'm putting this in the video so you have the most updated information. Slight risk all the way from eastern Pennsylvania all the way to eastern Illinois here. Marginal risk surrounding it further just off the edge here up towards the eastern seaboard and to southwestern Illinois. Okay, so tornado risk has been extended further westward as well into parts of Illinois and Indiana, although it's a low risk. Okay, so wind risk, well, hail risk here first. The hail risk is highest in this hatch area, as far as not highest as in percentage wise, but impacts. Okay, so anywhere in this hatched area, you have potential for 2-inch hail. Okay, outside the hatched area, you still can have 50% chance of hail here, but maybe an inch of diameter. Okay, so in the brown area, an inch of diameter hail as well. You can see even within the hatched area and the brown area, you could have a 2-inch hail also. All right, so wind risk, of course, is encompasses the slight and marginal risk here as well, with winds possible 50 knots or greater within 25 miles of the point. So that's the latest update for severe weather for today. Let's start this off by overlaying this these 3 different panels with a SPC outlook. So this is as of 6 p.m. today, right? You have the SPC outlook highlighting the slight and marginal risk areas. So I'm going to take this off. All right. So we know where that is now. Okay. And I want to draw this real quick here. So let's see here. You see this boundary right here? You see this boundary where the dew points are as well. You see where the storms are firing along that boundary. All right. So we have this northerly flow and southerly flow here. Wherever this boundary is where we have the best potential for rotating storms. And you guessed it, you have that here on the right panel. Okay. So as this boundary moves to the south, you see the line of storms moves to the south. Maybe some back building on the back side of it here, right? Let's take this dew point panel off so we get a better look at it. And you see even down here, you see this boundary right here, all right? What maybe looks like a surface flow generally in this area here, interestingly enough. So, because you have a northerly flow here, this is 925 millibars. So, it's possible that we have a little bit of a surface flow developing in this area. So, if that does happen, we could have some more vorticity with this and could lead to a more potent severe threat out to the west here. Okay, and again, this moves further to the east, and then points where you may have had severe weather. You may have some backside snow here, and you got heavy rain along the eastern seaboard with this, at least into 9 a.m. on Monday morning. Maybe a little bit of chance of snow, some snow showers or something on the backside here, with more of a northerly flow setting up here. Even down south here, you see we have more of a northerly flow at the upper levels, lower levels of the atmosphere. So that's part of what's driving this here. So when we look at severe setup, what we look for in the atmosphere is instability, right? And we got plenty of that here, especially in the Ohio Valley, and points to the east here with a sharp cutoff in the extreme eastern part of this area, right? We start off the day today. We already have some pretty steep mixed layer Cape values here, 700 joules per kilogram. Steep, not meaning steep. Impressive. Steep lapse rates, not steep Cape values. So this is pretty impressive for this time of year. Cape values to 3,000 joules per kilogram here as we get into the day today, into the evening, especially on the western side here in the Ohio Valley. So if we can get storms of fire in this environment, and this is the NAM model, so it could be a little bit too aggressive, right? But we'll compare the models in a minute. But I wanted to show you one of the model representation of the Cape values here. So this is one parameter. Now the other one is wind shear. So in the same area, we have pretty high wind shear values here as this moves to the south, right? And like I said, I think there's a surface low developing in this area here, okay? So if we can get some storms of fire right around where the surface low is, we could definitely see some rotating storms here, okay? So with these shear values, we also look at the helicity values as well. Let's take helicity here. You see right around when that surface low might be, the helicity values are maximized, right? And when you have values approaching 500 meters squared per second squared at the lowest levels and the up, that's incredible. And what I'm going to do is go over some soundings for this area too, just to see what it looks like throughout the column here next. So now I'm going to review some soundings from the different areas ahead of this line as it moves through, right? So if you try to analyze it with the the precipitation and it gets contaminated. So let's take a look at the wow. Okay, this is a sounding from southern Pennsylvania. You see all the dry air here. Oh my goodness! Look at how steep this lapse rate is. My goodness, surface to 8.3 Celsius per kilometer. This is definitely an inverted V type profile, okay? And so what does this tell us? Lots of dry air aloft, and hence the the hail threat in this area. Very steep lapse rates, okay? So once we reach the convective temperatures, definitely could have some hail here if the storms could get going, right? So that's that area for southern Pennsylvania, like right in there. Let's go to the Ohio area here, down here. Not quite as much of an inverted V profile, right? Still steep lapse rates throughout the column, okay? Very dry air aloft. See the D cape down here, value, downdraft cape. That's a measure of the potential downdraft force of the winds when the storms down through the column. So the dry air aloft will help propel the energy down towards the surface and higher winds. Okay, so that's a pretty high value right there. All right. So ahead of this backside stuff, I'm going to move this forward a little bit and get a sounding right from Indianapolis, Indiana. And you see right here at the lowest levels, there's a pretty stout mid-level cap here. And let's see if we can erode it all as we go forward in time. It really doesn't look like it's ever broken here because you see the dotted line is the parcel. We're not getting enough cooling aloft to release that cap. So if that cap can't erode enough, then we're not going to get surface-based convection. We could have elevated convection, which could lead to large hail, some hail and winds, but not likely tornadoes, okay? So let's move down a little further south towards let's see here. In Kentucky, the warm nose aloft is even steeper down here, so you'd see the surface lapse rates, and we don't really ever break that cap. So um, hence the problem with getting surface-based convection on the western side of this as well. So let's just take one more sounding from the central New Jersey here. Very steep mid-level temperatures as well here. Pretty big cap at the mid-levels. So that's got to be overcome. So let's see if it can be. Never really overcomes a cap here either. Okay, not enough cooling aloft to do that. So um, most likely be elevated convection, which could lead to high winds, of course, but not tornado-based threat. So back to the tornado-based threat real quick. Let's look at the parameters right where the greatest tornado risk is. Let's see the Pennsylvania border here. Take a look here. There's not really a cap as much here, and we have pretty steep lapse rates throughout the column. We could get some surface-based storms here. Let's move through time a little bit. The cap erodes a little bit more. We do have some skinny cape here, so hence the possibility of storms in this area. So Supercell Composite, significant tornado parameter. We have plenty of cape, although the shear profile is pretty straight here. The possibility of tornadoes definitely exists in this area. As far as the timing goes, I don't expect any storms to move into our area of interest until the afternoon hours, okay? So you could probably go to church and do things you normally do, right? And the convection will fire first in the mid-Atlantic in Pennsylvania in the 6 p.m. hour. Okay, and this is triple R, high resolution run. Then you have some convection fire in the backside of this, maybe into the high valley as well as we get into the evening hours, okay? And then it wants to show some back building convection as well. Will likely be elevated convection at this point, all right? More of a linear type threat here. And if we do get some storms of fire on the backside of this and the higher K values and things like that, we could get some heavier storms here, but you see it congeals into more of a just straight line convection overnight into the morning hours. So initially, we got the big threat for hail. If we get some supercells here, you see these supercells maybe developing right here. So we'll have to see how this plays out in this environment, okay? I'm just reviewing it again just to go over it. You see how it congeals into one big blob here, I guess you would say, as we get into the morning hours. Well, I want to remind everybody that there's multiple ways to get alerts, from the weather radio to your phone to um, local sirens, although sirens should be only relied on as the last thing, because sometimes you can't hear them. They probably won't wake you up, right? So if your area has sirens, don't rely on that exclusively. The more alerts you can get, the better. Of course, a weather radio has to have a battery in it, so if your power dies, it'll still function, right? Um, and get weather alerts from National Weather Service. You can select those from your phone, or you can pay for various services to get those too. And sometimes your local emergency managers have ways to receive alerts that are free as well through their website. So you could check out that too. So I'm just reminding y'all to be safe out there. Have multiple ways to receive alerts, and be safe, like I said, and God bless and take care.